Yellowstone's Biscuit Basin just did something the Earth here has never done in front of scientists before, and the moment it happened, it was captured by the single best instrumented patch of ground anywhere in the park's history. On June 23, 2026, a brand new pool that hadn't even existed 2 weeks earlier erupted in a single violent burst, throwing steam and near-boiling water dozens of feet into the air. That eruption wasn't a one-off, it was the final act in a chain of events that started 10 days earlier. A chain that scientists are now calling one of the most important hydrothermal sequences ever recorded, not because of its size, but because of exactly where and how closely it was watched. By the time this video ends, you'll understand why a research camera aimed at an unremarkable patch of dirt may have just captured the first real warning signs science has ever gotten before one of these disaster strikes, and why the ground under Yellowstone's boardwalks is doing something scientists have quietly feared for years. Let's set the scene properly, because the timing here matters. At 5:09 in the morning, Mountain Daylight Time on Saturday, June 13th, 2026, monitoring equipment inside Biscuit Basin picked up a sudden spike of seismic energy paired with infrasound, a pressure signal too low for the human ear to register. The source appeared to be coming from the direction of Black Diamond Pool, the same feature that on July 23, 2024, blasted rock and scalding water 400 to 600 feet into the sky and tore apart a boardwalk full of tourists seconds after they fled. Biscuit Basin has been closed to the public ever since that day, so when instruments lit up again before dawn on June 13th, the assumption was obvious. Black Diamond Pool had gone off a second time. Except the data refused to cooperate with that story. The temperature sensor sitting inside the pool itself barely twitched, registering only a minor blip before settling right back down to background levels, nothing like the abrupt signature that has marked every one of the pool's past eruptions. Something had clearly exploded somewhere in that basin. The seismic and acoustic readings left no room for doubt about that. But it hadn't come from the pool everyone had their eyes locked on for 2 straight years. The real answer came from a camera installed at the site in May of 2025, specifically to keep watch on Black Diamond Pool after its infamous 2024 blast. At 5:09 and 50 seconds that morning, that camera caught a dark plume of steam jetting skyward, not from the pool itself, but from a stretch of flat, forgettable ground a few dozen yards to its north. Terrain that had never done anything notable in recorded history. That single detail is the thread running through everything that followed. For nearly 2 years, every eye, every sensor, every worried headline had been fixated on one famous pool. And the Earth chose to tear open right next to it instead, in a spot nobody had bothered watching closely at all. That's not a comforting pattern if you're trying to predict where the ground will fail next. It suggests the entire underlying plumbing system is far less predictable than anyone monitoring a single famous hotspot would like to believe. When geologists reached the site the following day, they didn't find one new opening. They found 3, arranged as separate vent groups punched into ground that had been solid the previous afternoon. Large volumes of near-boiling hydrothermal water had surged out of these vents and poured straight downhill into the Firehole River. Most of the vents had already gone quiet by the time the team arrived, but the northernmost one, the vent farthest from Black Diamond Pool, was still actively flowing. That vent was connected to a jagged crack running north-northwest, stretching roughly 18.5 meters, about 61 feet long. In places, it gaped as wide as 1.5 meters, close to 5 feet across, wide enough that a person could fall straight through it. The water pouring out measured around 90 degrees Celsius, 194 degrees Fahrenheit, essentially the boiling point at Yellowstone's elevation. This was not gentle runoff seeping out of the hillside. This was violently pressurized, near-boiling water forcing its way up through newly broken rock. Here's where the scientists themselves want you to keep perspective, because the rocks thrown out by the June 13th blast only scattered a few meters, a sign that the explosive force involved was genuinely modest, especially set against the 2024 event, which hurled debris across roughly a full square kilometer. Judged purely by the size of the bang, this was a small hydrothermal explosion, the kind of thing that happens somewhere in Yellowstone roughly once every year without making national news. But you didn't need to stand at the vents to see that something significant had happened underground. Downstream, the Firehole River turned a pale, milky gray, visible from the road, visible from bridges, visible for miles. That discoloration stretched about 6 kilometers, roughly 3.7 miles, drifting steadily toward Midway Geyser Basin throughout the day. It was, in effect, physical proof that the shallow plumbing system beneath Biscuit Basin had just violently flushed a massive volume of sediment-choked water out of itself in a matter of minutes. Visible confirmation of an invisible process happening just beneath people's feet. And this is exactly where the story stopped resembling anything scientists were used to. Because the explosion on June 13th wasn't the end of the event. It was only the opening move and something that kept unfolding for the next 10 days. And what happened next has no real precedent in the observatory's history. When the Yellowstone Geology Program team returned to the site 2 days later, they found something that hadn't existed when they'd walked that exact ground less than 48 hours earlier. A new pool had appeared near the middle group of vents, filled with vigorously boiling, gray, sediment-thick water, and it hadn't formed the way these features normally do. Most new thermal features at Yellowstone are explosion craters, punched outward with a visible ring of ejected rock and debris scattered around the rim. This pool had none of that. There was no apron of blasted material anywhere around its edges. According to the United States Geological Survey, this pool didn't form through an explosion at all. It formed through collapse, the ground simply caving inward into the hot, pressurized zone beneath it, sinking down until the resulting depression filled with boiling water. Geologists on scene described hearing a distinct thumping sound coming from inside the pool, caused by steam bubbles forming and then collapsing beneath the surface. A sound one team member later admitted was genuinely startling to hear coming from ground they'd been standing on 2 days earlier. The measurements make this collapse feel tangible rather than abstract. The new pool came in at roughly 6.5 by 5.3 meters, about 21 by 17 feet, a hole the size of a small backyard swimming pool that simply did not exist when the geology team last walked that exact patch of dirt. And it didn't stay quiet for long. By June 18th, the pool had begun erupting on its own, cycling through multi-minute episodes of spouting that threw water 6 to 9 meters into the air, roughly 20 to 30 feet, the height of a 2 or 3 story building, and scientists described it as roiling vigorously even in the gaps between those geyser-like bursts. Then, on June 23rd, 10 days after the original blast, the pool let loose with a single, more forceful eruption, setting steam and near-boiling water surging upward in one sustained burst. Think about what that sequence actually represents. Explosion tears open the ground on day 1. 2 to 3 days later, that same ground silently caves inward, giving birth to a boiling pool with zero warning. 5 days after that, the new pool starts spouting on a rhythm of its own. And 10 days after the first blast, it erupts again, this time even harder. That is not a hazard that peaked and faded. That is a system that kept actively failing, kept finding new ways to open the Earth for the better part of 2 full weeks, right underneath ground that scientists themselves had been standing on hours before it gave way. There's something uniquely unsettling about a feature that forms through collapse rather than explosion, and it's worth sitting with why. An explosion is violent but brief, a single terrifying release. That's over in seconds and leaves obvious debris as a warning marker. A collapse is slower, quieter, and in a strange way far more dangerous precisely because it gives so little visible indication beforehand. It means the rock and soil beneath the surface had already been hollowed out or weakened to the point where it could no longer bear its own weight, and it simply waited on no predictable schedule until it finally gave way into the superheated water below. A person could have walked directly across that ground the morning before it collapsed and felt nothing unusual underfoot. That is precisely the scenario that keeps hydrothermal researchers awake at night, because it means solid-looking terrain inside an active national park can silently transform into a boiling hazard with essentially no visual cue at all. Now here's the number that turns this from a routine, if unusual, geological event into something genuinely historic for the field. That number is 100 meters, about 328 feet, the distance between the June 13th explosion site and a dedicated monitoring station, the Yellowstone Volcano Observatory installed at Biscuit Basin only the previous summer in 2025. According to the USGS, no hydrothermal explosion in recorded history has ever occurred this close to a purpose-built monitoring station. To understand why that detail matters so much, compare it directly to 2024. When Black Diamond Pool detonated that July morning, there was no dedicated hydrothermal monitoring equipment anywhere near the site. The observatory's wider regional network barely registered the blast at all. One of the most dramatic hydrothermal explosions in the park's modern history happened, and the scientific instrumentation charged with understanding it almost completely missed the moment it occurred. Researchers were left reconstructing what happened after the fact, piecing the story together from scattered debris and eyewitness photos rather than real-time data. This time, everything was reversed. There was a seismometer essentially standing next door. There was an infrasound sensor listening for the acoustic signature of rock fracturing. There was a temperature probe sitting directly inside the pool. And there was a camera aimed squarely at the ground, positioned in the right spot at the right second to catch the plume the instant it broke. The surface. Multiply that across 4 separate sensor types, all running simultaneously, all within a football field's distance of where the Earth actually tore open, and you get something the field of hydrothermal science has essentially never possessed before. A clean, close-range, multi-instrument recording of an explosion unfolding in real time from inside its own blast radius. Yellowstone Volcano Observatory scientists have already installed temporary seismic stations across the basin, specifically to capture the aftershocks and ongoing evolution of these new vents. And they've stated plainly that they'll spend the coming weeks combing through the data looking for one specific thing. A precursor signal, some detectable warning sign in the minutes or hours before the ground gave way. To understand why that search matters so profoundly, you have to understand the actual mechanism driving these explosions. Because it isn't magma, and it isn't the supervolcano stirring beneath the caldera. Underneath Yellowstone's shallow thermal basins, hot water constantly circulates through a maze of narrow cracks and channels in the rock. That water carries dissolved silica picked up at depth, and as it rises and cools, the silica precipitates out of solution and coats the walls of those underground channels in a hard, glassy mineral layer. Over time, that layer can thicken enough to seal a channel completely, sealing off a pathway that had previously let heat and pressure vent safely to the surface. Once sealed, the pressurized, near-boiling water trapped beneath that cap has nowhere left to go. Pressure climbs. Temperature climbs. What you end up with is essentially a natural pressure cooker sitting just a few feet underground that families walk across every single summer, and it can look completely stable right up until the sealed rock simply cannot hold anymore. When it finally fails, pressure drops instantly. The trapped water flashes explosively into steam, and depending on how the surrounding rock responds, the ground either blows outward violently or, as Biscuit Basin demonstrated over the following 10 days, destabilizes and sinks inward instead. If the close-range data from June 13th shows a genuine warning sign, a slow creep in ground temperature, a subtle shift. In infrasound, a flicker of micro-earthquakes building in the hours beforehand, it would represent the first real foothold science has ever had on forecasting one of these events, even a few critical minutes in advance. But there's a darker possibility, sitting right alongside that hopeful one, and scientists studying this data are being candid about it rather than sugarcoating it for public consumption. The 2024 explosion at Black Diamond Pool gave essentially no detectable warning beforehand, no meaningful spike in seismic activity, no obvious shift in ground temperature that anyone flagged in advance. If this new data set, captured from just 100 meters away with 4 different overlapping sensor types, also comes back showing nothing conclusive in the lead-up to the blast, then the far more unsettling version of this hazard gets confirmed instead. It would mean these explosions can strike out of apparent calm with effectively zero detectable precursor on terrain where several million people walk casually every single summer season. Either outcome carries enormous weight for how the National Park Service manages hydrothermal risk. Going forward, and this is genuinely the first moment in the observatory's history where scientists have had close enough data to even ask the question with any real confidence in the answer. To understand why the specific location has been so restless for so long, you need to rewind to where this entire chapter of the story actually began, because June 13th, 2026 didn't come out of nowhere. It's the latest entry in an almost 2-year pattern that started on July 23, 2024, when Black Diamond Pool erupted just before 10 in the morning with tourists standing directly on the nearby boardwalk. That blast sent mud, rock, and scalding water rocketing 400 to 600 feet into the sky, scattered debris across roughly a full square kilometer, and tore the boardwalk apart in a matter of seconds. By something close to a miracle, nobody was injured. It's worth being precise about what that event actually was and wasn't. It was not the Yellowstone supervolcano stirring, and it was not magma pushing toward the surface. It was purely a shallow hydrothermal explosion, driven by exactly the same pressure cooker mechanism we just walked through, only at a dramatically larger scale than what unfolded this June. What matters most, though, is what happened after that first blast. Biscuit Basin closed for the remainder of the 2024 season and has stayed. Closed ever since, and in the time since, Black Diamond Pool hasn't gone quiet. It erupted again in May of 2025. It produced a muddy eruption in December of 2025. Most of these follow-up events went essentially unwitnessed by the public simply because the area was already fenced off, but the instruments and the occasional trained observer kept quietly logging them. Stop and consider what that ongoing closure actually represents, because it's easy to glance past a line like the basin remains closed without absorbing what it means. An entire thermal basin inside the single most visited national park in the United States, a place that once drew steady streams of tourists along its boardwalks every summer day, has now been fenced off from the public for nearly 2 full years. Parks don't make that call lightly. It is the National Park Service stating, in the most concrete way available to them, that the ground in that basin genuinely is not safe to stand on. and that judgment has not softened with time. It has only been reinforced by every smaller eruption that's followed. Step back and look at the full pattern laid end to end. A major explosion in 2024, a string of smaller eruptions running quietly through 2025. And now, in June of 2026, a fresh explosion tears open brand new ground directly beside the original pool, followed by 10 days of ongoing collapse, spouting, and a final forceful eruption on June 23rd. That is not a system that blew once and settled back into equilibrium. That is a shallow, underground plumbing network that has been actively reorganizing itself, finding new weak points and opening new pathways for the better part of 2 years, and shows no sign of returning to anything resembling stability on its own. That pattern is exactly why the online reaction to all of this has gotten the actual danger so completely backwards. Every time Yellowstone does anything, even slightly unusual, the same predictable wave rolls across social media within hours. The supervolcano is waking up, officials are hiding an imminent super eruption, new vents and rising steam are the final warning sign before something continent-ending. It's worth addressing that directly, because the real science here is both more reassuring and, in its own way, more genuinely interesting than the myth people keep repeating. The data flatly contradicts the super eruption narrative. Yellowstone's volcano alert level has remained at normal throughout this entire sequence, and the aviation color code has stayed green. During the month of June 2026, the University of Utah Seismograph Stations, which operates the park's seismic network, located 118 earthquakes across the entire region, and the largest of them measured just magnitude 2.4, a tremor most people wouldn't even notice if they were standing directly above it. There has been no significant ground uplift or subsidence detected across the broader caldera since January of 2026, and nothing in the wider magmatic monitoring network suggests magma is rising toward the surface anywhere near this basin. A hydrothermal explosion like the one on June 13th is a shallow local steam event, driven entirely by circulating groundwater and near-surface pressure just a few feet down. It is not caused by magma, and it is absolutely not a precursor to any kind of caldera-scale eruption. On that specific question, the underlying science is calm, consistent, and well documented. That is a great way to wrap up the narrative. It effectively transitions from the specific details of the Biscuit Basin event to the broader consensus, more sobering reality of hydrothermal hazards, while simultaneously debunking the supervolcano myth with the calm, scientific. Since you asked for the processed lines to meet the strict 135 by 140 character limit per line, here is that final segment formatted as requested. It'll be one of the clearest signals available about whether this 2-year sequence has run its course, or whether Biscuit Basin is simply not done yet. Given the pattern stretching back to July of 2024, with repeated eruptions through 2025, and now this extended 10-day sequence in June 2026, there's little reason to expect the ground here to fall silent anytime soon. None of this changes the underlying science on the question people actually panic about. The Yellowstone supervolcano is not waking up. The seismic data, the deformation data, and the broader magmatic monitoring network all say the same calm, consistent thing they've said for years. But what the ground inside this specific basin has just demonstrated, in more detail than scientists have ever captured before, is that it can tear open without warning, quietly collapse days later into a boiling void that wasn't there before, and continue erupting on its own unpredictable timeline for well over a week afterward. That is not a story about a supervolcano threatening the world. It's a far more immediate and, in some ways, far more sobering story about how little separates a family walking a boardwalk in America's first national park from ground that has already proven, twice in 2 years, that it can fail without asking permission first. If you found this breakdown useful, it genuinely helps the channel when you take a second to like the video and subscribe, because there's a real chance this data ends up reshaping how hydrothermal hazards are monitored across the entire park. And when the observatory publishes what they found in that close-range recording, this channel will be covering it in full. Drop your own take in the comments. Do you think the data ends up showing a real precursor? Or does this confirm that these explosions truly can strike without warning? Thanks for watching, and I'll see you in the next one. But here's exactly where the doommongers online consistently get it backwards. And it's worth sitting with this for a moment before we close things out. There's a real hazard here. It's simply not the one from the disaster movies. The honest, documented danger at Yellowstone isn't a supervolcano erupting beneath your feet. It's a thin, sealed crust of ground holding back. Near boiling, pressurized water in places where families walk casually every single summer, ground that can give way with little or no warning at all. In 2024, it destroyed a boardwalk full of people within seconds of them managing to flee. In 2026, it silently swallowed ground a scientific team had walked across just 2 days earlier. The fear driving the supervolcano panic online is a real, human fear. It's just aimed at entirely the wrong target. People picture a magma chamber sitting miles beneath the surface when the thing that could genuinely hurt someone is sitting a few feet under their own boots. To keep that danger in honest proportion, it helps to understand roughly how often the ground here actually does this. Small hydrothermal explosions on the scale of what happened on June 13th aren't especially rare events in the grand scheme of Yellowstone's history. Something roughly this size occurs somewhere in the park about once a year, quietly enough that most visitors never hear about it. Larger events become progressively rarer as the scale increases. An explosion on the order of the 1989 pork chop geyser event, which left behind a debris apron roughly 15 feet across that's still visible today, comes along maybe once every several years. An explosion powerful enough to leave behind a sizable lasting crater happens on the order of once every few centuries. And the truly massive events, the ones that carve out craters larger than 10 acres, occur perhaps once every several thousand years. For a sense of just how large that upper end can get, the biggest hydrothermal explosion crater on the planet sits along the northern edge of Yellowstone Lake. A feature called Mary Bay, roughly a mile and a half across, blasted out an estimated 13,800 years ago. Measured purely by raw physical size, June 13th sits comfortably near the small and relatively frequent end of that entire historical scale. What makes it worth this much attention isn't the size of the bang at all. It's the unprecedented combination of two things happening at once, the closest any hydrothermal explosion has ever occurred to a dedicated monitoring station. And the very first time scientists have watched on camera, a brand new pool form purely through collapse and then begin erupting on its own schedule over the following 10 days. So here's what actually matters going forward and what's genuinely worth watching for in the weeks ahead. The Yellowstone Volcano Observatory is now sitting on a data set, unlike anything it has ever had access to in the history of hydrothermal monitoring anywhere in the park. And the central question hanging over all of it is whether that close-range recording shows a genuine precursor signal in the minutes or hours before the ground gave way. If researchers find one, and there's real reason for cautious optimism given how comprehensively this event was captured, expect this to be remembered as a meaningful, tangible step forward in the ability to forecast these events even slightly ahead of time, something that could eventually inform closures, evacuations, or trail warnings before a blast rather than only after one. If the data comes back clean instead, with no clear warning sign anywhere in that 10-day window despite 4 separate instrument types recording from 100 meters away, expect scientists to say so plainly rather than dress it up, and expect Biscuit Basin to remain closed for the foreseeable future, because that outcome would confirm the hardest possible lesson, that this particular stretch of ground can fail with genuinely no advance notice at all, even under the most intensive monitoring conditions science has ever thrown at a hydrothermal basin.